So we're starting in 9-1. So the first problem that we're talking about is in how many ways can you arrange 5 books on a shelf? So think about it. I've got like 5 little spots. 1, 2, 3, 4, 5. How many options do you have for the first spot? How many choices do you have? 5. Good. Then you pick one book. And now how many options do you have for the second choice? 4. And you pick a book from that. And then how many options do you have for the third spot? 3. And then 1. Good. So 5 times 4 times 3 times 2 times 1. And we could do that in the calculator. And that would give me 120. There's a shortcut on how to write this. Does anyone know what that shortcut is? Not a permutation. You're close. What'd you say? Mm-mm.
Pardon the interruption. Is Drew Ditto in the classroom?
Yes, he is.
And then the student services.
Yes, I can.
Thank you.
Bye, Drew. What I'm looking for is the word factorial. So we're going to do 5 exclamation point. And that exclamation point means factorial. And all that means is you're taking that number and you're multiplying by all the numbers less than it. So I can do any number factorial and it's just like that number and then that number minus 1 and then that number minus 1 and then that number minus 1. And it's called factorial. Factorial. Okay. Number 2 says, in how many ways can 9 people stand in line? We could do our little dashes out again, but based on the problem we just did, how could we arrange 9 people in a line? 9 factorial. 9 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 9 factorial. And the more of this we do, the better I think that this is an answer. 9 factorial is a much better answer, but let's actually practice plugging these in. Oh, I should have said that a second ago. You're probably like, this is cool little exclamation point, but like, how do we do anything with it? So let's do 5 factorial. Let me prove that 5 factorial is the same as 120. So I'm going to do 5. And then I'm going to go hit the math button on my calculator. Do we have to write what like this? Factorials, yeah. So I wrote 5. All I did was I typed 5 and then I hit math. And then I'm going to scroll over. Do you see how one of the last options is PRB on my calculator? Yours might say PROB. That means probability. So in the math section, I've got different menus, and one of those menus says PRB or PROB, which is probability. So anything I want to do with probability is in here. And so if you look, number 4 has an exclamation point. So that's the one I'm going to pick. I'm going to go down to number 4. I'm going to press enter, and you physically see 5 exclamation point in the calculator. And I press enter and I get 120.
How do we get to probe again?
Go to math and then scroll over to PRB or PROB, and then you can scroll down. So I'm going to do the exact same thing with 9 factorial. That's going to be a bigger number. So I press 9 and then I hit math again. I go over to PRB and I can go down to my exclamation point, my factorial, and I can press enter. And truly, I'm too tired to read those long letters out, those long numbers. So just bear with me. If we put it in actual number form and not just leaving it as 9 factorial, this is what we get instead. Okay, is that familiar at all to anybody? Yes, no, maybe?
Not the PROB part.
Not the PROB? Okay, that's fine. All right, the next one's a little bit funny, but we're gonna do it anyway, and I'm gonna kind of talk more about it later. So I'm putting a little mark on number 3 because I'm going to come back to it later. I'm going to do it now, but I'm going to come back to that concept later. It says, in how many ways can prizes be awarded for first, second, and third place in a race with 10 contestants? Okay. So if we're running in a race, we have 3 prizes, first, second, and third. Does it matter if you run and you get first place or if you run and get third place?
Yes.
Yeah, it does matter, right? It means something. The other class said no, and then I was like, well, does it matter if you get a gold or a bronze medal at the Olympics? And then they were like, yeah. So yeah, first is different than third, and that's different than second. So all of those are different spots. As we're running the race, how many people have the ability to win first? One person will win, but how many people are racing for that spot? 10. 10 total people.
I thought we were talking about 3 in the word problem.
10 runners.
Oh, okay, I'm thinking about 30.
Oh yeah, there's 3 places that we're gonna fill, but 10 people can make it. So, I mean, it's not like there's no one winner yet. So all 10 of them have the opportunity, have the ability to win first. Now, once somebody wins first, how many people could win second?
9.
Good. And then after someone wins first and second, how many people could win third? 8. Now we stop there because I don't want to know how many ways can everybody get place. I just want to know what are all my options for first, second, and third place. So that's it. I'm going to just go put that in the calculator. 10 times 9 times 8. And I get 720. So of a race of 10 people, there's 720 ways that we could name first, second, and third place. Now I'm going to give you a shortcut to that at the very end of class. So we'll come back to that idea. But as you guys told me, I'm going to write this next to it. I'm going to write order matters. It matters what order we pick the people. It matters what place you win. It all matters. It's important. That's going to be important because soon we're going to see some that where order does not matter, and that's going to be a difference. Okay. The next 2 problems are pretty similar to each other. The first one says, Mrs. Ford has 8 jumpers and 10 shirts. How many different outfits are possible? Anyone have any ideas? How many outfits could she make? MK? You good? Not just 8.
80.
Why 80? I think you're right, Will. Why?
10 times 8.
Why'd you do 10 times 8?
10 shirts and 8 jumpers.
Good. So for every jumper she has, she can wear 10 shirts with it. And I could do the second jumper and she has 10 shirts to wear with that. And I can do the third jumper. So we just are taking the amount of things that we have and multiplying them together. So 8 times 10 means that we have 80 options. All right, similarly, now we got to get Mr. Ford figured out. He has 5 sports coats, 12 shirts, and 10 pairs of pants. Assuming that everything matches, how many outfits does he have? What math are you doing in your head right now? 600. We're doing 5 times 12 times 10. 5 times 12 times 10. Again, we're just making all the arrangements, all the different ways we can separate them and match them up together, which will be 600. Good. Okay. Questions or concerns yet? All right, number 6 says, in how many ways can the home row of the keyboard, A, S, D, F, G, H, J, K, L, be arranged? How many ways can we arrange those letters on that home row of the keyboard? Why 9 factorial? Good, and then so on and so forth, right? So there are 9 total letters and we're just arranging them. So I'm going to say 9 factorial. And you can put that back into your calculator if you want, but I think it's fine as is. So I'm going to leave it there. 9 factorial. Now I'm going to make a little note at the top of my paper though. I'm going to say arranging in a row or a line. That's just going to be the number of things that you're arranging factorial. So that's the same thing as n factorial. So arranging things in a row or a line is n factorial. We're going to do other ways of arranging things later. So I like to make note of anytime it's in a line, I'm just going to do n factorial. All right, let's carry on. Number 7 is a little bit different. It says, in how many ways can you answer 10 true false questions? Okay, I personally like these little lines. If you hate them, you don't have to use them, but I like these little lines. And so I'm thinking, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions. How many options do I have for possible answers for that first question? 2, right? It's either true or false. All right, cool. So I decide the first one's true. What about the second one? How many options do I have? Why is it 2 again? It's true, false. Could I have all trues in a row? Could I have all falses in a row? Is any problem ahead of it dependent on the other problems? No, it doesn't matter. So all of these little blanks will be 2. 2 times 2 times 2 times 2. How many times am I doing 2 times itself? 10. So I can put in my calculator 2 times itself 10 times. Is that the same thing as 10 times 2? It'd be 2 to the power of 10. So that's a really easy mistake that I don't want us to make. So that's the same thing as 2 raised to the 10th because you're doing 2 times itself 10 times. And I will put that in the calculator, 2 caret 10, and I get 1,024. And either answer is fine, 10 or 2 to the 10th, or this 1,024 is a totally acceptable answer. And 2 happened because it didn't matter, no matter what I was doing, I still only had 2 options for every question, and I was doing 10 questions just like that. Okay. Number 8 is a lot like number 3. This time it says, how many ways can 4 different prizes be given out if there are 10 people in the contest? Okay, it says 4 different prizes. Do you think those prizes, it doesn't matter if you're called for the first prize or the second prize? Or the third prize or the fourth prize? They're different prizes. What's one prize you could get? What? A ball? Yeah, you could get a ball as a prize. Couldn't you also get like a car as a prize? Wouldn't you be like, feel kind of gypped if you got called and you got like a ball, like just a basketball, and then the next person who got called got like a new car? I'd be like, what the heck is this? That means it's different, right? That means order matters. So I'm gonna write order matters next to it because it matters if you get called to get a basketball or if you get a whole new vehicle. Those are 2 different prizes. So order matters. Say again. If it's a kickball, I still want a new car, right? I guess we can. All right. Okay, Jane, we will agree to disagree. So I have 4 prizes. How many people have the possibility of winning the first prize? How many names am I picking from? Now I pick one. He gets thrown out because he got the ball. What happens for the next prize? How many options do I have there? 9. Very good. So this time again, we don't go all the way. We just go 4 spots because that's how many prizes we have. 10 times 9 times 8 times 7. And I get 5,040. Again, I've got like a little gray circle on number 8 and number 3 because we're going to come back to those later. 8 and 3, those are the same type of problem, and I will do another one like those at the very, very end of class. 8 and 3. We're figuring out how many ways prizes can be awarded, and in those cases, it matters what order you pick the person. Okay. Anybody questions yet? All right, the rest of this page are all similar types of problems. They're talking about call signs and license plates. Let's do license plates because most of us drive cars. We've seen license plates before. It says how many license plates are possible if they consist of 2 letters followed by 3 non-zero digits. Okay, so I'm going to put my little lines out. I've got 2 spots for letters, and I've got 1, 2, 3 spots for numbers or digits. Okay, I personally haven't thought about how many letters there are in the alphabet for a very long time, but 26, if we remember all the way back to like 1st or 2nd grade, whenever we learned that, kindergarten, who knows. 26 letters in the alphabet. Now it says the first 2 are letters. If I picked A for the first one, can I pick A for the second one? Sure, right? Does it say any reason that I can't have the same letter twice? No, if it doesn't tell you, then we assume that it's totally fine. So I'm going to assume that I've got 26 options for the first one and 26 options for the second one. I could do A and A, Z and Z, M and Y. I don't know. I've got a bunch of options. Now for my digits. How many total digits are there? 9 and 0, which makes 10, right? Now this time it says it wants non-zero numbers, so we're only going to do 9 of them. But if I just said use all the digits that we have 10 singular digits, 1 through 9 and 0. So we would use 10 normally. However, this problem specifically says you may have non-zero numbers, so we only get to use 9 digits. And there's no thing about repeating or not repeating here, so we're going to assume that you could use 111 or 333. Okay. Now you can put that in your calculator by just doing 26 times 26 times 9 times 9 times 9. Or if it makes you happy, you can do 26 squared times 9 to the third, because I've got 26 times itself twice and 9 times itself 3 times. Either way, you're going to get the same answer as long as you do the right thing. And I get this giant number, 492,804. Okay, cool. Yeah, Ellie. I had to put 9 because there are 9 total digits that I'm allowed to pick from. So that's not representing a digit. That's representing like how many digits I can choose from. All right, number 10 is using the same concept. It says how many plates are possible if no letter or number can be repeated. Okay, so we've got the same setup as before. I still have 1, 2 spots for letters and 1, 2, 3 spots for numbers. How many letters can I use for my first choice? And how many can I use for my second choice if I can't repeat any letters? 25, good. All right, now I'm thinking about digits. So now I don't care about the numbers anymore. How many total digits am I allowed to use? I'm still going to use 9 because I'm still considering the one above. I'm not using any zeros. And then I can't use the one that I just used for my first digit. So how many options do you have for your second one? And then, good. So 26 times 25 times 9 times 8 times 7. There we go. You see how that's a little bit less than the one we did above it? Okay. I'm going to do number 11, then I'm going to have you try 13 and 14. So I'll get you started because they all rely on 11. It says, how many 4-letter call signs are possible if every letter is allowed? Do you guys listen to the radio? Anybody? I don't really anymore, but you know the radio has like 4 little letters. It'll say like, yeah, one of those, or WZPL, I think is it. I listen to NPR and that's WFYI. So like they all have 4 letters and that's how the radio works. And so that's what we're thinking about here. So 4 letters. And this one says how many call signs are possible if every letter is allowed? So how many options do I have for the first letter? And how many for the second letter? 26. How many for the third letter? And good. So in that case, I do all 26s because it doesn't say anything about repeats. It doesn't say anything about vowels. It doesn't say anything about consonants. I just assume I can use any letter as many times as I want. So that's like 26 to the 4th. And that's the same thing as this big number. Now I want you to take a minute. The 3 underneath it are using that exact same concept, but they are having little different requirements. So see if you can figure out the next 3. I've got the 2 above it up. Okay, take another minute or two, finish those two up, those three up. All right, you guys ready to talk about 12, 13, 14? All right, what'd you do for number 12? What was the work that you did? What times what times what times what? Good, and what told you that we had to go down each time? No repeats, good. I'm not gonna put that in the calculator, is that okay? That's okay? Yes, okay. I can't tell if some of us are actually asleep or just not listening, so. What about the next one? How many are possible if no vowels are allowed? I don't know what the final answer is. What did you multiply to get there? Not 20 to the fourth. I did 21 to the fourth. Which, oh, I didn't count Y. We debated that last class. What do they teach you guys these days?
Why is a vowel?
I don't think so. Back in the 90s, Y was not a vowel. So that's what I'm going off of. What about in the 2000s? What do we decide about vowels? Sometimes. Sometimes Y. I think they changed the alphabet since I got out of elementary school. Either if you like had justified that, I would have just been like LOL Ava on your paper, and then I would have been like, that's fine. Because of what I'm teaching you is the math, not how many vowels there are, so or what the vowels are. So, all right, what about the last one? How many are possible if no vowels are allowed and no repetition is allowed? What would I multiply there? 21, 20, 19, 18. Perfect. And if you put these in the calculator, you would see that these are decreasing values. But for sake of time, you know how to multiply 4 numbers in the calculator, right? Perfect. I hope so. All right, flip your paper over if you're doing paper. If you're doing online, just scroll down. It's not nearly as satisfying. All right. This next problem says, if a baseball team has 9 starters, how many different batting orders are possible? Baseball players, what do we think? 9 exclamation point. 9. 9 factorial. Why is it 9 factorial?
You can't like bet the pitcher twice in the lineup.
Yeah, you can't bet anybody twice. Everybody has to go one time around. It's like we're putting them in order in the line, and then they just go down the line and they hit and hit and hit, right? That's just basically baseball, right? Yeah. Just kidding. I understand more about baseball. What did you say?
Said some of them strike out.
Yeah, so some of them don't make it. Okay, next though, it gets a little complicated because it says how many are possible if the pitcher bats last? So how can I make a lineup if I know the pitcher is going to go last? Start with what? So if I know one person has to go at the end, I can't consider him for first, right? I've already taken him. I put him at the end of the lineup. So that means I only have 8 options to start with. I am going to write this one out just because you're right. We do start with 8. It's going to be 8 factorial, but it's like if I have 5, 6, 7, 8, 9 spots, the last spot is just one option. You don't have multiple options. There's only one pitcher. So we only get to bat that pitcher last. That means that going on up the line, I've got 8 factorial. So 8, 7, 6, 5, 4, 3, 2, 1. And all of those numbers are being multiplied by each other. So it doesn't matter that I've got a couple ones at the end because anything times 1 is just itself. So those ones are kind of redundant. It's just the same thing as 8 factorial. Anybody have questions on that? Okay, we have to use that concept for the next one, which says how many are possible if the pitcher bats last and the best hitter bats third? 7 factorial. So exact same ideas we had before. If you don't like the little dashes, you don't have to do them. but the pitcher goes last, so we know that I only have one spot for the last spot. And the third is my best hitter, which there's only one best hitter, right? You can have a lot of good hitters, but somebody has to be your best hitter. So that means if I already take those two people out of the lineup, then that means I only have 7 others to play with to fill the other spots. 7, 6, skip over 5, 4, 3, 2, 1. And I can have as many ones as I want on this lineup. It just means I have less opportunities and less possibilities because now I'm down to 7 factorial, which, as we would assume, is going to be less than 8 factorial, and 8 factorial is less than 7 factorial. So one thing you should think about is every time we like make some kind of stipulation or make some kind of rule, then that means that like we have less options than what we started with. Okay, this next one's kind of a weird one. It's the only type of this problem that we'll do today. We'll see other ones like it later, but I still wanted to kind of talk about it today. It says how many 1-digit, 2 digits, or 3-digit numbers can be formed using the digits 1 through 6? Okay, how many 1-digit numbers can I make from 1 through 6? 6, right? Okay, what about a 2-digit number?
36.
Why 36?
6 times 6.
I have 6 options for my first digit and I have 6 options for my second digit, which means that I've got 36 options. And then what about a 3-digit number? So whatever 6 times 6 times 6 is. Because I have 6 options for each one of those places. 6 in the 10, 6 in the 100, 6 in the, I forgot ones. 6 in the 1, 6 in the 10, 6 in the hundreds. Okay, now that I have these options, I'm not going to multiply them separately together. I'm going to add them together. So the key word here is or, and again, we'll do more of these problems on another day. But anytime I say it's okay if we have this, or if we have that, or if we have that, we add them together. So it's going to be 6 plus 36 plus 216. Which last time I did this, I got 258. Sorry, what'd you say? Oh, you want me to start all the way over on that problem? Are you okay with the 6, the 36, and the 216? So it says a 1-digit. So that means in each digit spot, I only have 6 options. 2-digit. Now I have 6 options for the 1s and 6 options for the 10s. So 6 times 6 is 36. And then 3 digits, I've got 3 spots for those 6s to go. So that's 216. And the keyword or means that I add them together. Means that I add them together. All right. The next two say how many 5-letter words, and it uses words in quotations because I don't mean like English words or words that we know, just like 5-letter, I guess, combinations of letters can we make from the words Chevy? How many ways can I rearrange all of those letters in the word Chevy to make new words? Well, if I have 5 letters, how'd you get that? Well, we don't have just 3 places to fill. We've got 5 places to fill. And once you pick one letter to go first, what letter goes? How many letters do you have to pick to go second? 4. And then once I pick the second letter, how many options do I have to go after that? And 1. I know it sounds almost boring, but it's these 5-letter words. It's the same thing as rearranging it in a line. So I can think as arranging in a line. And as we said at the top of our page, anytime we're arranging in a line, that's the same thing as the number that I have factorial. So you can do your 5 times 4 times 3 times 2 times 1, but that's the same thing as 5 factorial. We're just arranging it in a line. Okay, same idea for the one underneath it. How many 6-letter words can be formed using the letters in the word PreCalc? What? Oh, 6, yeah. And then, yep. and then on, right? And that's the same thing as what? 6 factorial, good. And again, you can put that in your calculator, or 6 factorial, I think, is just as good of an answer. How we doing? Everybody with me? Okay. The next one is talking about a social security number. How many of you guys know your social security number off the top of your head? Oh my God. I did not know mine until I had to be like a big girl and fill out job forms and stuff. So if you don't know yours, no worries. I had a job when I was in high school though, where like a part of our login into like the system was the last 4 of our social security. And that helped me start to know those. So the last 4 are good to know, if even at your age. But how many letters are in a social security number? Does anyone know? It's 3, and then it's 2, and then it's 4. So 9. And this one says, we want to know if all arrangements are possible. So social securities are made up of numbers, right? 9 numbers. How many digits are possible for any one of those spots? 10. You can have 0 in your social security. Can you have repeats in your social security? Sure, why not? So every one of these boxes can be 10. So you don't, if you hate these little dashes that I draw out, you don't have to use them. I just get all bent out of shape sometime with probability. So I like to make it as like tangible as possible. But if you go, okay, well, I know that there are 9 spots and all of the spots have the option of 10 digits, then that's the same thing as 10 to the power of 9. Good, 10 to the 9th. Which I'm going to leave it as this. It would be a really big number in my calculator. Let me actually put it in. Oh, no, that one goes. We'll have to do a big one later on because sometimes that messes you guys up when we put it in the calculator. So remind me if you think that there's a really big one, we'll put it in and see if we can make sure we see it. But that's a million zeros. I know I lose track of that many zeros if I try and write it down. So 10 to the 9th is totally fine. All right, so that's a lot of possibilities. What would be cool is if we knew how many people had social security numbers and made sure that there were no repeats, right? Because the whole point of that is there shouldn't be any repeats. None of us should have the same social security number. How big is that number? Is that 1 billion? Yeah. There's got to be less than 9 zeros. I don't know. Do you think when people die, we reuse their social security numbers? I would guess so, right? This is such a dumb question, but are there more than 1 billion people in the US? How many people are in the whole world? 7 billion? Say again, Drew, I can't hear you. Only 400 million in the US? I feel bad for whoever's watching this YouTube. It's like, God, Miss White, you're so stupid. But I truly don't know. Okay. So technically we should be good, but think about how long has Social Security been around? Since the 50s or 30s, right? So there's been a lot of people who've gotten Social Security numbers. So something to think about. That's why it's so many digits, is if it was only 5, it would be hard to make that many unique numbers. So the whole point is we all get our own. So we have to have this many options. All right, similar thing with telephone numbers, right? There's significantly less people with a 317 area code than the people in the entire United States. But how many telephone numbers are possible with a 317 area code? How many more numbers, how many more digits are left in your phone number? 7, 3, and then 4? 10 to the power of 7, which will still be a really big number. Not as big as 10 to the 9th, but still a big number. Okay. The next 2 are very similar to ones that we've already done, but there's one key difference that we're going to have to deal with here. Are you ready for 23 and 24? Would you say? They repeat. There are letters that repeat in here. And if I was simply just rearranging the letters in the word pre-calculus, what happens if I switched the U's? Would that look like a different word to us? No, so we have to get rid of any repeats, because if I just switch the C's or the U's or any other repeats, it doesn't make a difference to my letters. So, okay, when we do this, we are going to start by doing the total number of ways that you can rearrange all the letters, and then we're going to divide off any repeats. What letters are repeats here?
C-O-U.
C, yep, L, and U. Perfect. So let's build our fraction. What's the total number of letters here? How many total number of letters in the word pre-cal? 11, good. So we're gonna say 11 factorial on top. So if those are 11 unique numbers, we would be done. However, we said C repeats, U repeats, and L repeats, so we have to get rid of those. How many times does C repeat? Twice. So we're gonna divide by 2 factorial. Because we have to get rid of when, we can count when they're like this, but I can't count when they reverse. So I have to get rid of that repetition. What about L's? How many L's do I have? 2, so I'm gonna divide by 2 factorial again. And then what about U's? How many U's do I have? 2. 2, 2, 2. Now, this is an okay answer to leave it like this, but let's go put it in the calculator and see what I get. Let me actually do 11 factorial by itself. So 11 factorial, I got kind of a decimal, which is kind of odd, but I get this huge number. When I do 11 factorial divided by 2 factorial by 2 factorial by 2 factorial, I will be able to get a much smaller number. So when I plug this in the calculator, I'm going to go do my 11 factorial. Everything's well and good. I'm going to put a division sign. I'm going to write divide, and then I'm going to put everything in the denominator in parentheses. If you don't put it in parentheses, it will just divide by the first 2 factorial, and then it will multiply by the other 2 factorial, and I don't want that. So I'm going to do parentheses 2 factorial, 2 factorial, and you don't need to put any multiplication signs in there. It's just assuming, and then 2 factorial. 11 factorial divided by 2 factorial times 2 factorial times 2 factorial. And that's, again, I don't know why my calculator is giving me weird decimals, but it shouldn't. Do you get that whole number on yours? 4989600. That's what I get. If you go to math and then scroll over to the probability menu under math, and then it's number 4, the exclamation point. Do you see it? Mm-hmm. 4989600. 4 million something something something. All right, let's do the same idea with the letters of Mississippi. How many letters of Mississippi do I have? It's 11 again. Okay. What repeats do I have? How many times does S repeat? 4. How many times does I repeat? 4. How many times? Any other repeats? P. How many times does P repeat? 2. So I got to divide off by 4 factorial and 4 factorial and 2 factorial. I got to divide by all of those things. So I'm going to write 11 factorial divided by, and again, I'm going to put parentheses in the bottom. Don't forget your parentheses. 4 factorial, 4 factorial, and 2 factorial. And my parentheses. Good, and because I have so many repeats here, this is a much smaller number. Even though pre-calculus and Mississippi both have 11 letters to start with, Mississippi has a lot more repeats, so it has significantly less ways for us to rearrange it because there's only so many places and ways you can put the S's that is new and unique. Okay, you guys are doing great. We're actually almost done, so let's just finish up where we're at. I've got 5 more questions. Okay, number 2 is an interesting one. It says, explain why at least 2 students must have the same first and last initials at Cathedral. How many options do you have for your first initial? 26. How many options do you have for your second initial? 26. You could repeat, right? Some people have the same first and last initial. So I'm going to do 26 times 26. and I get 676. How many kids go to our school? More than that, right? So just by probability, there are more students that go to our school than 676. So there should be at least one set of students that have repeating first and last initials. Can anyone think of any? Do you have any initial twins? Me and Meredith Ward have the same initials.
Andrew Damasales.
And you? Nice, yeah. He doesn't go to our school anymore, but yeah, that would have kind of.
Actually, since last year.
Did he graduate last year?
His little brother.
Drew goes since when? Since he graduated. But yes, you guys would have had the same initials. Anybody else think of any?
Nick Davis.
Jake Davis and Joao. Yes, very good. Chase, you and Corbin have the same initials. Uh-huh. I'm sure if I thought about it, I could think of more for most of you. It's funny when I send emails to other staff members, like if you ask me for a note, like when I send an email for Dom to be here, I'll put like DS in the subject line. So every so often I have to like think about who I'm writing about or who I have in class, because I just wrote like DS and I'm like, oh my God, which kid is that? So I think of your initials all the time. But yeah, so because that's how many students it takes to have a repeat, we should at least have one or two or more repeats because of how big Cathedral is. So that's kind of fun, a little fun way that we use probability, right? Don't have too much fun. Because we're barely hanging on. We're almost done. Okay, you ready to revisit the ones we did at the very beginning of class that I promised we'd look at again? I'm sure you were waited with bated breath to do ones like 3 and 8 again. Yeah. Okay, the time has come. Here we are. So we're going to do this exact same problem, but I'm going to have a new word for it. So this first one, in how many ways can a club with 20 members choose a president and a vice president? Before I teach you the shortcut, how would you do this? How would I show that how many options I could have to pick a vice president and a president from 20 people? What'd you say? Someone say something. Grace? Good, yeah, so because I have 20 people that I can choose from, I have 20 options to pick for president, and then once I pick one of them, I have 19 options to pick for vice president. So let's do that in the calculator really quick. 20 times 19, that is 380. Okay. Now this type of problem, wait, does it matter if is order important here or not important? Does it matter if you're president or vice president? I think it would, right? We can ask Joan Kamala if we want to, but I think it matters which one you are. Order matters here. This is what we call a permutation. A permutation. A permutation is a way to pick a certain number of people or things, and it's where order matters. Order is important. And there's a button in the calculator for this. So see how it says permutation? If I go back to my math menu and go find my exclamation point, do you notice that number 2 says NPR? So that P means permutation. So I'm going to click the NPR button. And in front of the P, I can put a number, and behind the P, I can put a number. The number that goes in front is how many total things you can choose from. So the biggest number always goes first. In this case, I've got 20 students to choose from to get president and vice president. So 20 goes before P. Now, if you have an old calculator, I don't know if I can see any from here, you won't be able to type it this way. So if you try and copy me, let me know if you can't do it that way. So I clicked NPR and then I wrote 20, and now I can kind of arrow over. And then the second number is how many spots you want to fill. So how many spots do I want to fill right now? 2. I just want to fill a president and a vice president. So I want to fill 2 spots. So 20P2. And if I press enter, that should be the same thing as 380. Oh, and it is. How fun is that? Yeah, Ellie. Okay, you might need to write 20 first. So I want you to type 20 and then go to NPR. Yeah, and then put 2. Because 19 is just how many we multiplied. 2 is how many spots we want to fill. So how many spots? Yeah, 20. Then NPR. And then write 2. It's on my demo. And then scroll over to the RV, and then yep, and then you can fill it in just like this. So whatever colors you want to use. Does anybody else need calculator help? 380 represents how many options you have to pick a president and a vice president. Do you want to listen to permutations? Oh, you guys are still chapter 7. Ooh, fun. All right, so permutations, order is important. Now, letter B, it says, how many ways can you choose a 2-person governing council? Does it matter on your 2-person governing council who's called first and who's called second? They have the same job, right? They're equal level, so it doesn't matter if I say like me and then you or you and then me. It doesn't matter what order we go in. So essentially, I'm still filling 2 spots, and I still have 20 options for the first one, and I still have 19 options for the second one. But because it doesn't matter what order you pick, I have to divide off half of the options. Because one half of the options might be like me first and then Seth, and then the other option might be Seth and then me, and those are the same options. So we're going to divide that by 2. Now, I can't promise this works for all of them. I didn't explore this a little bit more, but I'll show you the button, the calculator we're going to use. But if I did 20 times 19 divided by 2, that's 190. This is called, thanks guys. This is called a combination. And so instead of permutation, we're doing what we call a combination, where order doesn't matter. The best example I like to give for this is like captains. Most of us are on some kind of team where you have captains. And like the title of captain doesn't give anybody more responsibility or less responsibility than anybody else, right? We're all kind of the same level as a captain. So combination is where order doesn't matter. Captain is different than principal and vice principal or president and vice president. So when I go in the calculator, instead of saying NPR, I'm going to do NCR. And that's right next to the NPR. So if you go over to your probability, number 3 says NCR. I'm going to click that, and I'm going to fill the numbers in the exact same way I did before. How many total people do I have to choose from? And how many spots am I trying to fill? 2. So I'm going to do 20C2, and I get 190. So these will look super similar in the calculator. It's really important that you know which one is which, NCR or NPR. All right, I've got 2 more questions, so we have to decide which one's permutation, which one's combination. Are you ready for the last 2? Okay. The first one, letter A, says, in how many ways can a club with 13 members choose a 4-person leadership team? That's a combination. Very good. Because it doesn't matter what order they're picked in. They're just a leadership team, so it doesn't matter. So I'm going to use, is it P or C? Which one do I use? C. Good. What's the number that goes first? 13, because I've got 13 people to choose from. And how many positions am I trying to fill? 4. So 13C4. If you try and do it the other way, it will not work. So I feel like every year I have people who are like, well, it won't work. It's probably because you put them in the wrong order. You always put the bigger number first and you put the smaller number second. So 715. The only difference on the last one is this time it says president, vice president, secretary, treasurer. Does the order matter here? Yes. So which button do I press? P. 13P4. Again, looks almost identical, but once you do the math, look how many more options I have when I do P versus when I do C. So many more options. All right, that's all I got for you today.